Switch case. The switch case statement is a fundamental control structure in many programming languages, including Java, C#, JavaScript, and Dart, among others. It provides a way to execute different sections of code based on the value of a variable, making it a powerful tool for managing conditional logic in an efficient manner. Unlike a series of if-else statements, which can become cumbersome and less readable with multiple conditions, the switch case structure offers a more organized and straightforward approach to branching logic. The basic syntax consists of a switch keyword followed by a variable or expression enclosed in parentheses, followed by a series of case statements that define possible values for that variable. Each case statement ends with a colon and is followed by the code to execute if that case matches. Importantly, each case should ideally end with a break statement to prevent fall-through, where execution continues into the next case unintentionally. The switch case construct is particularly useful in scenarios where a variable can take on a limited number of distinct values. For example, in a weather application, you might use a switch case to handle different weather conditions like sunny, rainy, or snowy. This would allow you to encapsulate the logic specific to each weather condition in a clean and manageable way. Suppose you are building a function that determines the type of weather display to show based on a string value representing the weather condition. Using a switch case, you could structure your function like this. Moreover, switch case statements can be particularly advantageous in terms of performance. In some programming languages, switch cases can be optimized by the compiler to use a jump table, leading to more efficient execution than multiple if-else checks. This can be especially significant when dealing with a large number of cases, making switch statements a preferred choice in performance-critical applications. Another noteworthy aspect of switch case is its versatility. While many programmers associate it solely with integers or strings, modern programming languages have extended this functionality to allow more complex data types and expressions, including enums, which can help categorize values more explicitly. For instance, in Dart, you could define an enumeration for weather conditions and use it within a switch statement to handle cases in a type-safe manner. This approach enhances code reliability and readability, as it restricts possible values to a predefined set. Switch case statements can also be nested, allowing for more complex decision-making structures. For instance, if your weather app had a feature that varied its functionality based on both the type of weather and the severity, example light rain versus heavy rain, you could nest switch cases to handle this effectively. However, it's essential to use nesting judiciously, as overly complex structures can lead to decreased readability. In terms of best practices, it's important to handle the default case in every switch statement. The default case acts as a catch-all for any values that don't match the predefined cases, ensuring that your application can gracefully handle unexpected inputs without crashing. Including meaningful feedback or logging in the default case can also aid in debugging, allowing developers to trace issues effectively. Furthermore, the switch case structure enhances the clarity of the code, allowing other developers, or even your future self, to understand the flow of logic quickly. This is particularly valuable in collaborative environments where multiple individuals may be working on the same code base. Code that is easy to read and maintain reduces the likelihood of errors and streamlines the development process. Real-time weather app. Building a real-time weather app is an exciting endeavor that combines user interface design, data management, and API integration to deliver valuable information to users. The primary purpose of such an application is to provide accurate and up-to-date weather information based on a user's location or a specified city. The process of developing a weather app typically involves several key components, including designing an intuitive user interface, fetching data from a reliable weather API, and displaying that data in a user-friendly manner. At the core of any effective weather app is its user interface, UI. The UI must be visually appealing and intuitive, allowing users to navigate seamlessly while accessing the information they need. Key elements of the UI include a search bar where users can input their desired location, buttons for refreshing the data, and clear displays for current temperature, humidity, wind speed, and forecasts. A minimalist design approach can enhance user experience, ensuring that essential information is highlighted without overwhelming the user with excessive data or clutter. Using consistent color schemes and typography will also help create a cohesive look throughout the app, fostering a sense of professionalism and reliability. To provide users with real-time updates, a weather app must integrate with the reliable Weather API. APIs like Open Weather Map, Weather API, or AccuWeather allow developers to access current weather data, forecasts, and additional meteorological information. Upon selecting an API, developers must sign up for an API key, which authenticates requests and often allows for tracking usage limits. Once the API is set up, the next step is to implement data fetching within the app. This is usually done using asynchronous programming to ensure that the app remains responsive while waiting for data from the API. In Flutter, for example, developers might use the HTTP package to send requests and handle responses. The fetched data is typically returned in JSON format, which developers can then parse into usable objects. Creating model classes that represent the structure of the JSON data can simplify this process, enabling easier data manipulation and display. Displaying weather data effectively is essential for user engagement. Once the app fetches the data, it needs to present it in a way that users can quickly comprehend. Using visual elements like icons for different weather conditions can enhance the user experience. For example, sunny conditions might be represented with a bright sun icon, while rainy weather could use a cloud with raindrops. Additionally, implementing charts or graphs can help users visualize trends over time, such as temperature changes throughout the week. Real-time functionality can be further enhanced by allowing users to set their favorite locations for quick access. This can be achieved by implementing local storage solutions, such as SQLite or shared preferences, to save user preferences. By doing this, users can easily switch between different locations without having to enter them each time, improving the app's usability. Furthermore, integrating geolocation services can enable the app to automatically fetch weather data based on the user's current location, offering a seamless experience that doesn't require manual input. Security is a critical consideration in any app, particularly when handling user data. Developers should ensure that all API calls are made over HTTPS to protect data in transit. Additionally, it's important to implement proper error handling in case of failed requests or issues with the API. Informing users of such issues through meaningful messages can prevent confusion and enhance the overall user experience. As technology advances, there are many opportunities for enhancing a weather app. For example, incorporating machine learning could allow the app to offer personalized weather insights based on user preferences and behavior. Similarly, push notifications for severe weather alerts can keep users informed in real time, adding significant value to the application. Such features not only improve the app's functionality but also foster user engagement, encouraging users to return to the app for updates. Fetch data from API. Fetching data from an API is a critical aspect of modern application development, particularly in data-driven applications like a weather app. APIs, or application programming interfaces, serve as bridges between different software applications, allowing them to communicate and exchange data. In the context of a weather app, an API provides the necessary access to real-time weather information, enabling the app to deliver accurate and timely updates to users. The process of fetching data from an API typically involves making HTTP requests, handling responses, and integrating the data into the application seamlessly. To begin fetching data from a weather API, developers must first choose a reliable service provider. Popular options for weather data APIs include OpenWeatherMap, Weather API, and AccuWeather. Each of these APIs has its own unique features, endpoints, and pricing models, so developers must assess their specific needs before selecting one. After choosing an API, developers typically register for an API key, which is a unique identifier that grants access to the service and tracks usage. This key must be included in each request to authenticate it, ensuring that the API provider can monitor and manage usage effectively. Once the API is selected and the key is obtained, the next step is to understand the API documentation. This documentation provides essential information about available endpoints, request parameters, response formats, and rate limits. Most weather APIs follow a RESTful architecture, meaning they use standard HTTP methods such as GET, POST, PUT, and DELETE to interact with resources.
The end.